All right, so in this video lecture right here, we are going to look at a topic that is, to me, it's extremely vital for students who are planning to go into calculus, because right in your calculus 1 course, this idea will be very emphasized right there, okay? And but sadly, throughout many textbooks that I've used for teaching, this topic is only discussed as a small topic in a section of a chapter. So, but feeling the importance of this particular topic, I have decided to make its own video lecture right here. Okay, so that the student will have a focus and emphasized instruction about this particular topic right here. Okay, and so I will introduce what a difference quotient is, and we will have a good look at the different examples like that. And before we move on right here, it is highly recommended that this lesson right here is to be viewed after you have learned about how you can evaluate a function at an expression, at an input being an expression. And usually it is also recommended that this particular lesson is learned after you have understood about what a function composition is, or composition of functions is. Okay, but more importantly, this lesson here should be learned after you have learned about how you can evaluate a function at an input that is being an expression. Okay, but that's all we need. And other than that, all of your algebraic skills that you've learned from your prerequisite courses need to be brought in here. Okay, so let's get started with the following promoting problem right here. I'm going to promote the idea here by introducing a problem. So let's start out by looking at a given function being f of x equals x squared. Okay, and for those who have studied with me here throughout earlier video lessons, then I've also brought in the what's so-called the toolkit functions, or somewhere here and there I also refer to them as the common functions like that. So yes, this function is chosen from one function among the toolkit functions, but being really, the point now is that being whatever function that is, it's not important. What we have here is a given function. Okay, and so now from your skill that you have previously learned about how to evaluate a function at an input that's being in an expression, then let's do the following problem. Simply, so right out from that lecture where we've learned about the kind of problem where we evaluate a function at an input being an expression, let's do another problem just like that. Okay, just keep the problem like that. Don't worry about what exactly a difference quotient is. So I want you to follow along with the following problem. Let's say from that given function, let's evaluate. Okay, let's evaluate. And for now, there will be some more instruction to this, but I'm going to come back and add in some more wording to that. But let's just simply evaluate the following expression right here. F of, how about 1 plus h, okay, minus f of 1, and divided by h. Okay, f of 1 plus h minus f of 1, and divided by h. All right. Let's have a moment to observe and have a close look at this particular expression right here. So we are asked by this problem right here to evaluate this expression. Okay, but what is involved in this expression? It's a fraction. It's a rational expression. It's a fraction. Okay, the numerator here has two terms. There's one term here and there's one term here. Okay. And so now, let's break it down one by one right here. So I'm going to step over to my other board and use that space there as scratch work, because as I have recommended throughout some of my other video lessons, when we're doing math, especially the kind of math at this level in a pre-calculus course right here, then use a lot of scratch work, okay? And use as much as scratch paper as you can. So from what I've seen in the expression, there was this f of 1 plus h being involved in our numerator of that previously written expression. and that was right here. All right, so that f of 1 plus h. So I wrote it down separately just to, you know, give a detailed, a thorough investigation of what that is. Okay, so in that way, let's look at what this means. So at this point, after we have seen those kind of problems where we are asked to evaluate a function, because f is a function, it's a rule. Okay, so after we have seen how we have done those problems, after you have learned from my lecture about how we can evaluate a function at an expression, okay, at an input being an expression, specifically that's what it is, then here's how we can do it. So this skill is not new for us at this point if you have learned that skill previously before this lesson. Okay, so with that skill, how we can evaluate a function at an input being an expression like this, then the rule of our function is f of x equals x squared. Okay, quick reminder, f of x, and x is being the input, so it takes the rule of this function says, the rule of this function says that for every input we're going to square that input, and that's just simply the rule. So now in that way you have seen a lot of my explanations when we were doing those problems specifically. So now I'm going to look at that as 1 plus h all squared. Okay, simply just that. And that's how we have successfully evaluated our expression 1 plus h into the function. It was not a numerical value input. It was not a numerical value for the input, to be specifically clear. So that's why here we have no further, we have no choice rather than just simply plugging that 1 plus h expression into the rule, and so now we have produced 1 plus h all squared. Okay, of course we will eventually move on further, but for now, as far as evaluating the function f at this particular input being an expression, that's where we have evaluated the function at that 1 plus h expression. So now I'm going to bring this expression, okay, I'm going to bring this end result right here back to my other board. And so so now that work I've done there was just scratch work. So formally speaking, this is going to give me, so that first term after evaluating, it's going to give me 1 plus h all squared. Okay, and then the expression currently from the beginning here is telling me that after we have substituted the input 1 plus h into the function, we're going to need to also subtract. So this subtraction is after evaluating the function f at that input. And then continuing on, we're going to subtract, okay, so that subtraction sign is here. We're going to subtract the function output f at 1. Okay, so f at 1 at this point, for anyone who's learning up to this point right here, you should be fluent with what a function is and reading function notation. So needless to mention that at the beginning of this video lesson. And so the rule of the function f is still here. For every input, we're going to square the inputs. That's the rule to come out with the output. And the rule here is named as f. That's why we have the function's name and all that. So f of 1 here means according to the rule. Okay? According to the rule, I'm going to have 1 squared. So this particular part right here that I have just produced came out as a consequence of evaluating. So again, we evaluated 1 plus h into the expression, into the function f. And we also evaluated x equals 1, the input equals 1 into this into this function. We evaluate the function at this x equals 1 input. Okay, that's how I have produced 1 all square. Okay, and now over h. That was just part of the beginning expression right there. Okay, so now at this point I have, ladies and gentlemen, I have evaluated this expression here at indicated. But now, with a problem like this, simply an evaluation problem is not too fascinating. Okay, so now I'm going to go back to the instruction and say, so now how about after evaluating it? Okay, we want to simplify. Okay, so that's why usually it's about evaluate and simplify. Okay, and so now So after this evaluation point right here, and I have to make it clear again, at this point we are done with the evaluation. But what we realized up to this point is that we have ended up with an expression in terms of h. And so there's that h variable that remains right here as part of our overall expression here. And so we want to spend some time simplifying it to make it less complicated and less complicated. Okay, so starting from this point, whatever steps I'm going to take next, that's just entirely the work to simplify. Okay, and so now at this point, I'm going to start swinging back and forth between my two boards. The other side is my scratch work, here is just my formal work. So in how I'm seeing it right now, we can work a little further algebraically with this expression, because what we realize here is that we have a 1 plus h in parentheses square. This square here means we're going to think of this 1 plus h all square as an 1 plus h times 1 plus h. Okay, so let me quickly move to the other board and find out what that can be. So this 1 plus h all square here on scratch work, think of that as a 1 plus h times 1 plus h. Okay, and then throughout many video lessons of mine, I keep mentioning this. This is not the only way to get an answer, a FOIL answer for that. Okay, somewhere here and there in a course prior to this course, you might have picked up some fast trick to get it done. Use your trick right here. Allow me to show the method that's common to most of the students right here, but I'm not saying that this is the fastest way to get to the final FOIL of this square right here. Okay, so now I'm going to FOIL. All right, so 1 times 1 gives me 1. Okay, of course it's 1 square. 1 times h gives me h. h times 1 gives me h. And h times h gives me h squared. And that's what I meant by FOIL again. So I hope I don't have to keep mentioning about these elementary algebra work right there. Okay, because we're looking at this lesson at a pre-calculus course level. So now combining like terms, these two are like terms. So we're looking at 1 plus 2h plus h squared. But at least this is the end result. This is the end result for expanding. Okay, expanding this 1 plus h all squared. And by the way, formal or standard term for doing the foiling work on this, it's called the expanding. Okay, we have expanded that perfect square on the binomial here. Okay, and the expanded square is here. But the work really was foiling work. We foiled out, the product of two identical factors here. Okay, and so throughout years, many students of mine are more comfortable with just calling that this is the FOIL form of that. Okay, but formally it's the expanded form of that. So now I'm going to copy and paste this end result and bring it back, and because recall for yourself, this is just scratch work right here. So now that end result is going to be the next step of this particular square right here. So in my next step, 1 plus h all squared produce for me 1 plus 2h plus h squared. Okay, and in my style, anywhere that I substitute an end result for a previous step, or anytime I substitute an expression for another expression, I use the parentheses. And so this parentheses of mine indicating a group right here, this group entirely represents that 1 plus h all squared. So only that 1 plus h all squared is being replaced by this group, okay, being grouped inside of this pair of parentheses. And so after that first group, we still have to go with that minus because of the formula. And now 1 square is indeed just 1 numerically. So now it's 1. And then now, so I skipped the square, but really because I already squared and it still gave me a 1. But I'm still using that parentheses here to indicate this is another group that came out as the end result of squaring just that 1 right there. Okay, and then we're divided by h. And so now it's time to take away parentheses. Okay, so in front of this group right here, in front of this parentheses, it's just a positive sign. So taking away the parentheses here simply just give me 1 plus 2h plus h squared, and without worrying about sign changes or anything like that. and then I'm going to subtract 1, okay, and I'm going to divide it by h. All right, so now at this point we have produced for ourselves an expression where in the numerator we have recognized some opposite terms. Okay, so we can start canceling out opposite terms and combine like terms if there are any. So I recognize opposite terms. Okay, so 1 and negative 1 got canceled out. So now we're looking at a 2h. Okay, a 2h plus h squared divided by h. Okay, so each step I'm trying to move in small little elementary steps like that, so you can hopefully follow along. But when you are mature enough, you can start skipping some of the small steps. Okay, but how many steps you should skip? Usually it's hard to decide right there. So bring in as many steps as possible. Make your work as clear, as stepwise as possible. Okay, so after canceling the two opposite terms here, now I have ended up with 2h plus h squared over h. And so now if we're observing this numerator and the denominator together with that, both numerator and denominator have that common factor h. Okay, h is the common factor. So there are quite a few different ways to approach this, but I normally advise my students to factor out that common factor h in the numerator first. So let's spend some time doing one step right here. So h in parentheses 2 plus h, and then we're still looking at divided by h. Okay, so what I've just done here is simply the only work I've done, the only action I've made so far is to factor out that common factor h throughout my two terms in the numerator. And so what I did there, after factoring out that common factor h, I produced h times in parentheses as a group 2 plus h. Okay, but now the advantage of that, now all of a sudden I recognize this common factor h in the numerator is also common with that h in the denominator. So now we can cancel away that common factor that appear in both the numerator and denominator. All right, so algebraically, after we cancel that common factor h away, now we ended up with simply just that 2 plus h. And at this point right here, we realize that we cannot combine like terms anymore. We cannot cancel any further common factors or anything like that. Then this is where we call it's the simplified expression, the simplified final expression. So it's just that work throughout the whole work right here. It's just that work that we were doing when we're evaluating a function at an expression, and then evaluated a function at an expression, but then that's in a more like a combined expression overall like this. Okay, and then we ended up with this simplified final expression. All right. I didn't even mention what a difference quotient is yet, okay? But this work that we started, after we evaluated, we ended up here. And then from that successful evaluated point right here, we moved on and simplified. That's why the instruction of the problem said that we need, it asked us to evaluate and simplify. Evaluate it and spend our time to simplify. Okay? All right. Let's try again. Same function. So I see this as just like a drill that I want a drill that I want students who follow with this lesson right here to start really get comfortable with that. And as we've done many problems enough, we will start clicking into a certain routine right here, and that routine will drive us into that important concept that I'm about to introduce right here. Okay, same function. Okay, nobody needs to rush or anything like that. Same function. We don't have to worry about switching to a different function. Same function. Let's look at, so how about f, okay, at minus 2 plus h. So it's a brand new problem to be suggested here. Minus f at minus 2. And then we divide it by h. But before we proceed, I highly recommend start looking for something in common between this problem and the problem we have done already and erased. Okay? Try to look. I'm still gonna go through the steps formally. I'm not going to skip any step for this particular problem, but I highly recommend. I'm asking students who are learning with me, before I proceed, just right at that instance where you copy this down, start looking for things that's common. Start looking for anything that's common between this problem we're about to do and the problem we just done previously that was already erased. Okay, so and whatever you recognize, keep that with you. Okay, and we will get to that. But so for now, just if we're treating this problem as an entirely brand new problem, and here you go at start, you see f of minus 2 plus h, okay, minus f of minus 2 over h. Okay, let's get the problem done. The question here, the problem wants us or asks us to evaluate, okay, and once evaluated, simplify it. Okay, so let's throw in the evaluation work right here. All right, and one more time, I am going to swing to the other board to work with the evaluation. So we're still looking at the same function f of x that says we square every input. And so now, in that case, when we apply that rule f for this expression minus 2 plus h, let's see what that evaluation is going to look like. So the evaluated expression is going to look as following. And I don't think I need that fraction bar right there. Minus 2 plus h all square. Simply that's it. Okay. Now I have to open a remark here. So minus 2 plus h is also the same as it's the same as h minus 2. So this exact problem can sometimes be expressed as f of h minus 2. Okay. It's exactly the same expression. And then you can also evaluate that as h minus 2 all square. Okay, but indeed I want to purposely emphasize that part where the plus h comes after the number. Okay, and so this is the one I'm going to be proceeding with. Okay, all right, so now I'm going to bring this end result for now. Before simplification, I'm going to bring this end result back to my other board and substitute this for f of minus 2 plus h, because this is how I have just evaluated my function f at this particular input being an expression. Okay, so all right, so now that means in my numerator I'm producing the following. First term is going to give me as a group minus 2 plus h all square. Okay, so the work is almost exactly the same as that previous problem we were doing and erased already. And then now I'm gonna the starting expression here is indicating that after evaluating minus 2 plus h into the function, then we're gonna subtract. Okay, and now it's gonna be minus 2 all square. Once again, this is the evaluation of the function at input x equals 2. We go with numerical value this time. Okay, and over h. All right, and so in this way, now we have at this point we have successfully evaluated the function at that input and also the function at this input negative 2 and subtract the 2. Okay, and divide it by h. So this at this point right here, that's how we have evaluated this expression, this overall expression. But now it looks a little, lengthy and complicated. That's why we're going to spend some time simplifying. Okay, so simplifying it, again, I'm going to start out by do the foiling work on this perfect square right here. Okay, the formal term, it's the expansion work. I'm going to expand out this perfect square right there. All right, so I'm going to navigate to the other board again. So on this board of mine, I will think of this, and again, you could have picked up some trick here and there from your previous course of how to quickly expand this. Okay, but allow me to show this as a, in the most common method, the method that's common to everyone, the understanding that's common to everyone, so that anyone can follow. But I'm not saying that this is the fastest method here. I'm seeing this as just simply a product of two identical factors. Okay, so minus 1 plus h times, minus 2 plus h times minus 2 plus h. That's what I'm That's what I was saying earlier. I'm seeing this square as a product of two identical factors. Okay, and now that's where the foiling work is coming in. Minus 2 times minus 2 is minus 2r squared. Okay, and then minus 2 times h, okay, gives me a minus 2h. And now I'm going to go h times negative 2 gives me another minus 2h. And then I'm going to go h times h gives me an h squared, positive term. And now I'm going to combine like terms, and also I will square that minus 2 right there. And notice how the square is outside of the parentheses. That means it's negative 2 times negative 2. Okay? And so in this case, it's a positive 4 for that term. These two terms are combined together because they are like terms. So minus 4h, okay, plus h squared. And so this is the end result of expanding that perfect square right there. And like I keep saying quite a few times already, that I'm pretty sure you must have learned some fast trick to recognize that perfect square and quickly come with this end result, completely bypassing all of these foiling steps right here. So if you know that trick, go for that. I have no objection against that, but just allow me to go with this seemingly slower method, but common to everyone. Okay, so now that is my end result of expanding this perfect square right there, or foiling out that perfect square. So I'm going to bring this end result and bring it back to my other board. And again, whatever I've done there is just simply being regarded as scratch work. Okay, have that common habit with you. So once we've had that scratch work, we realize that this perfect square will become 4 minus 4h plus h as a whole group. That whole group there is what's going to substitute or replace this, okay, in the next step. But then I'm going to still use that pair of parentheses to indicate the whole group there is a substitution or a replacement for this perfect square. But so what's after that perfect square? We're going to need to subtract according to the setup of the expression. Okay, and now minus 2r squared. This is just simply a small math problem, so it's a positive 4. So it's the result for minus 2r squared. But I'm still going to put that in parentheses, indicating this is a group of value that came out from that particular term after the minus sign. And then there's still that h in the denominator awaiting for some actions on it. Okay, and then now, so in the next step, I don't think I need to keep moving back and forth any longer at this point. But so now we can start taking away the parentheses. So this group here, now let's ungroup it. Taking away parentheses is the same as ungrouping it. So ungrouping it was just a positive sign before in front of that group. So now taking away the parentheses, we will have to worry. We will no longer have to worry about sign change or anything like that. There's no sign change to worry about. So it's just 4 minus 4h plus h squared. Okay, and then that becomes a minus 4. And then over h. And so now I'm going to recognize there's 4 minus 4. They are opposite terms. Cancel them away. Okay, so here I'm looking at, in my next step, after canceling away the opposite terms here, I'm looking at minus 4h plus h squared and divided by h. Okay, and very similar to the work that I've done in the earlier problem, now I recognize in my numerator, I recognize that there's a common factor, and I highly recommend going that way, even though there are other ways you can do too. Some other professors taught their students at the prerequisite course to cancel the h away with that h and this h away with that h. That works, but to me it's still a little bit of a skipping step for them. Okay, and so now I factor out that h, that common factor h, giving me h times minus 4 plus h and divided by h right there. So that h in the denominator of the starting expression remains the same pretty much throughout the entire work until this step. And so now I'm going to recognize that there's this common factor h here is also common with that h in the denominator. So now we can cancel that. Okay, so now my real ending result here is going to be a minus 4 plus h. Okay, minus 4 plus h. And so at this point right here, I can see that there's no further like terms, there are no further common factors to cancel or to simplify. this is our simplified final expression right here. So we have done our work. We evaluated that expression here, that general expression at this point right here. And then after that point, we have successfully simplified. We spent a few steps and simplified it down to that's where we can no longer simplify. Okay? And so that's another problem right here. So 2 problems done in a row. Okay? And so now it's time for me to, and this is just like I didn't even mention what the difference quotient is. The topic title, the name that I was mentioned in the topic title, it still didn't get mentioned. Don't worry about that. Okay? Do not need to worry about that. How about allow me to ask viewers and students of mine who are following along with this lesson to do a problem on your own right here. Okay, so it's an FYT for your own trying. So an FYT means I'm not going to show the steps. I'm just going to write down the problem, and I will wait for you to get your own work done, and then I will just simply write down the final answer up here. Okay, but so here it is. All right, so the one I would like anyone watching this video to try is, how about f of 0 plus h, okay, and minus f of 0 and divided by h. Ladies and gentlemen, I have just now finished writing down that setup right here, and I'm asking you to try this independently on your own as your own trying. So this is an FYT for your trying, okay. But again, I highly recommend, as soon as right at that moment when you finish writing down this particular setup right here, this particular expression, I want you to look for what's common between the one you are about to do now with those you have done previously, including the one just now and the one even before that. Okay, because we have done 2 problems with me, and now this is one for your own trying right here. So start recognizing for some common things, right, or maybe the only common thing among those 3 problems that you're doing. Okay, so now go ahead and pause the video, take your own time, follow the steps. Okay, you can feel free to roll back the video lecture here. Okay, and to see the steps I took for the earlier problems right there, and then you can apply that here. All right. Okay, so now hopefully you have spent enough time and had your own answer for that, had your own final simplified expression. So that final simplified expression I have here is going to be just that h, just h. Okay, we simplified it down and it came down to just h. Okay, just h, nothing else. All right, and so it's an FYT, so allow me not to show the work right here. All right, but now let's move on. So you've done up to this point. I've shown 2 problems, and I left 1 problem for everyone. Or anyone who's watching this lesson to do on your own. So here, but at least let's now put the 3 problems together, your FYT and together with the 2 problems that I did on my own right here. The first one I came up with was f of 1 plus h. So how about this time, let me do this. F of 1 plus h. F of 1 plus h, okay, minus f of 1, okay, then over h. I purposely wrote that 1 in red ink right there for you to notice. It's a repeat. This part of f of 1 right here, it has that value repeated from here. So here it was 1 plus h, and here it was 1. And the same function, I mean whatever function. So maybe after this lesson here, you can try this exact setup with a different function. This function here is the x squared function. You can also start thinking, well, what if it happens on like a 3x minus 1 or something like that. Okay, a different rule, different function. But for now, let me emphasize on this. Again, I wrote this in red ink for a reason. Okay, and again, the next problem after that, so this was the first problem I brought up. The next problem was f of, and this was still the problem that I did together with anyone. It was, and that was the plus h over h, okay? It was minus 2 plus h, okay, minus f of minus 2. So f of minus 2 plus h minus f of minus 2. over h. And right at that instance where I wrote down this problem, I already started asking anyone viewing the lesson to start looking for common things. And now once we've all done with all three problems, including your FYT right there, now we can start putting I can put all these three expressions that we did, all these three problems at the starting point. I put all these three problems together so that we can start really and formally recognizing the common things between all these. Okay? And then the third problem that I put up for your own trying right here was that f of, again, or how about, let me write this on the other board right there. All right, so the third problem that you try on your own trying right here was f of and over h. See, it's so common that I can even just write down that common structure right there, and there's a 0. Okay. All right, so three problems I put on the board right here. Let's now look for what's common. Okay, so at this point right here, this is what common. At least my black ink, look for my black ink. My black ink has that, f of something plus h minus, and then now I wrote that red ink here is because you see that to emphasize it's repeated in this part right here. But then in a different problem, that red ink, can be switched to a different value, but they got again repeated among their two terms. But then the black ink is the part that being common throughout all three problems. So there's a difference. There's a difference in black ink. Okay, there's a difference. And there's a difference. That's the black ink part right there. And based on the function f, one term has that expression plus h. Just like that. One term, same function, black ink, okay, and has that expression plus h, okay. And then there's another black ink part that's quite important. Divided by a difference now in black ink, and divided by h, and divided by h. Three problems have a lot of things being in common, and all of those things together, I see them as one thing in common. Okay, so in any of those problems like there, what we have here generally is a difference. It's a difference. Okay, it's a difference, and the difference in function value. See, because it's f of function value, f of 1 plus h, f of minus 2, f of minus 2 plus h. So this is the difference in functions output, in function values. Okay, it's a difference. And then it had, outside of being a difference, it had a quotient. It's the difference here being part of a quotient. Top and bottom. Okay, difference being part of a quotient right there. And this, ladies and gentlemen, this is the reason why I refer to this as, so the first problem here, the formal name now. The formal name for the first problem here is called, okay, this is called the difference. Okay, the difference, because there was that difference. And there was this quotient, so this is called the difference quotient. Okay, the difference quotient. But then you see that emphasized number that I wrote in red ink right there. So now I'm going to say it's, this thing here is called the difference quotient at, okay, x equals 1. Okay, so that emphasized the value right there that I wrote. It's just my style to catch your attention, but then that value right there, that's why we call that, it's a difference quotient at x equals 1. This particular one right here in the box. Okay, that's how we call it. So now again, so well, that one I put in a box. So now what about if we didn't have that one? What about if I didn't look at that one and instead I looked at the second one? Okay, let's now turn our focus to the next one. So now I'm erasing that box away. So if we're looking at that one here, the second one, and putting that in a box to catch your attention. Then this thing, see, it has a difference again, and it's a quotient. That's why, again, this is called a difference quotient. Okay, arrow. This is called a difference quotient, but it's not at 1 anymore. It's not at 1 like this anymore. It's at, so what's that? What's that red value being emphasized here, being indicated here? -2. Okay, so now I'm going to say this particular one is called the difference quotient at x equals -2. Okay, -2. That's what it is. Okay. Now, to be even more precise, I should have also added in this term right here the difference quotient, but then of that function, because in every, see, it has that function attached to it. So precisely speaking, it's the difference quotient of the specific function f of x at this designated given value. Okay, so it's called the difference quotient of the function f of x at x equals -2, like that. And that's what this box was. And then this is the difference quotient of f of x at x equals 1. Okay, I'm verbalizing it out loud enough about 2 times already, 2-3 times, quite a few times already actually. Okay, so now let's go to the other board and look at how we can call. Just so here basically I'm focusing on the way how we call the setup. This setup has a name. The setup that we've been doing 3 times with 3 different values right here. Okay, 2 times was led by me, 2 times were led by me, and 1 problem was done independently by anyone watching the video. Okay, but now any one of these expressions right here, they are called, it's called the difference quotient, right, of the function at x equals whatever that value is. Okay, so now on my other board, so yes, I see a difference, I see a quotient. Okay, and that's on behalf of this function f right here, still related to that function f, still built on top of that function f. So yes, I will call that, this expression is called, okay, the difference quotient. Allow me to start using shorthand writing. It's not nice, but because there are a lot to write right there. The difference quotient of the function f of x, of course. Okay, but here at, so now what do you think? This has to be at x equals 0. That emphasized value right there. Okay, all right, so now that's the naming, and this is now what that's called the difference quotient, or a difference quotient, a difference quotient of a function, okay, at a specific given value. And so now that means generally speaking. So now generally, let me put this away. We come to a definition, or just simply, yes, it is a definition of what it means by calling it the difference quotient. Okay, so let f of x be a given function. All right, then in that way, the expression once f of x is given, the expression f of a, okay, plus h minus f of a, okay, all over h, that expression right here. Put a comma here for me, and put a little note where a x equals a is given. Okay, So x equals a is also given. But in the end, this expression is called, okay, the difference quotient of the function f of x at x equals a. All right. So this part right here where I underline with the red ink is the formal name of the entire setup right here. So that setup is specifically given that name right here. This is called the difference quotient of f of x, right, at this specific given value x equals a. Okay. All right. So at this point right here, we're gonna start getting comfortable with recognizing, you know, this difference quotient here through different examples, and then once we've recognized the difference quotient, we're gonna start getting into some examples again. Okay. So let's now get into our first example. Let's now call that example 1 right here. All right. And so now I wrote down the definition for not too long, and I kept it there for not too long, and then sadly I have to erase it because I will eventually write that remainder on the other board right there. Okay, but now I'm going to say, for this example, let's do the following. Evaluate and simplify, of course, just like how we were doing the problem earlier. Okay, evaluate and simplify the difference quotient of f of x at given value x equals a. Okay, so that's just a general instruction right here. But what clicks my attention and what caught my attention about this problem is the difference quotient of f of x. Okay, and then at x equals a. Okay, so now let's write down the first problem, part A right here. So how about the function we have here for this problem, connecting that with part A right here. F of x is how about defined to be 11x minus 4. Okay, 11x minus 4, and then the value here is, yes, at x equals 4. This is x equals a given right here, so it's given in the problem. The function is also given. All right. Okay, so on this board, I wrote down that brief description of the difference quotient here again, or that brief definition, so that I can maximize my board space and start writing down the example problem on the other board right there. But see, anytime we call anything a difference quotient of a function, any given function at x equals a, this is the starting setup for that. This is the setup that we had from the definition, and as we have already experiments through the 3 promoting problems, right, and agree with that, it clicked into that form right there. Anytime we've ran into this form right here, we call it a difference quotient. And then on behalf of that function f of x, and then at x equals a. Okay, and so now I'm going to apply what we have just learned, and this is just a way how we call it. Okay, so there's not too much about why we calling it that way. Why we calling it difference? Because there's a difference. And why difference quotient? Because there was a difference and there was a quotient. Okay, so from what we saw right there, we calling it that way. So not really too much about a reasoning or a why or anything like that. Okay. But so now, once we agree with what that way of understanding about it, then now the problem is asking us, hey, here's your function f of x. Let's set up the difference quotient. See, I want to evaluate, but in order to evaluate, we have to know how to set it up first. Let's set up the difference quotient on this given function. So this is where we are no longer in f of x equals x squared, f of x equals x squared was that function that I was doing for the introduction. Okay, but now see, now we're in a different function. So f of x equals, how about 11x minus 4, for example. And then that given value, x equals a, is now x equals 4, specifically in this problem. So let's learn how we can set it up first. So here's the setup. Now I want the difference quotient. So it has to be that, see, remember I talked about the black ink part when I was still explaining about what the difference quotient is. So it's f of, so I need a plus h component, and then minus f of, okay, and then divided by h. This is the difference quotient. The difference quotient of f. Okay, that's how I'm setting it up. What about the scary empty part I'm leaving here? Okay, it's not as scary because that is where this x equals 4 comes in. So 4 plus h, f of 4 plus h minus f of 4. Okay, that's the setup for that. That's the setup for this difference quotient. Okay, and so this is the reason why right now this problem is considered as part A. We will get to part B, and as we finished about a few problems, then you will also click into a good routine, a good habit of how you can set up a difference quotient at a given point. And then from there, now the work is going to go back to how I was doing that introduction work right there. So now the instruction here says we need f of 4 plus h. Okay, so on scratch work, again, even though we're in a formal example now, I still want to maintain that scratch work, the habit right there. So in this case, f of 4 plus h really equals to, it's the function f. In this case, the rule of f says 11 times the input minus 4. 11 times the input minus 4. So it's 11 times the input. The input is currently 4 plus h. So 11 times the input, 4 plus h minus 4. That's what it is. Okay, it's no longer square because square was for that function we've introduced earlier. But here it's a different function, different rule. So on this input right here, substitute it into the new function. 11 times the input. 11 times the input minus 4. All right, so now I'm going to copy and paste this end result, bring that into my function. So in my next step, the setup becomes the following. Okay, so this is the evaluation point right here, the point that we evaluating the function at this given expression 4 plus h. So now I'm looking at 11 times the input 4 plus h minus 4. Now I'm going to use a bracket right here to indicate this whole group right here is the end result for this f at 4 plus h. Okay, and now I'm going to subtract. Why subtract? Because the formula said so. Okay, and why is there a minus sign here? Because that's what the difference quotient is. Okay, that's all there is. We call this setup right here the difference quotient. So now we are specifically asked to do the difference quotient. That's how we're firing it up. Okay, and now we're going to follow along consequently. And now the next group here gives me, so 4 substituted into the rule here. And I don't think I need scratch work for this. I can write directly the work here. So it's going to give me 11 times 4 as the input and minus 4. Okay, so let me write it a little smaller so that it won't take too much, it won't be too squeezy. So minus 4 here, okay, and then minus, and now I'm looking at 11 times 4 minus 4. All right, so hopefully now that's readable enough for anyone viewing the video here. And then over h. Okay, so at this point, again, just like how I was doing the setting up problem right here, this is the evaluating step right here, the step where we have evaluated the function at these specific expressions like that. Okay, as at these specific inputs like that. Okay, and now the next step is to simplify. Okay, so evaluation is now done. Now let's simplify. So now in the next step, I am going to just simply multiply out that 11. Okay, and then here it's just simply in this group it's going to be just 44 minus 4. So we will get to that one by one. All right, so 11 times 4 is a 44 plus 11 times h is an 11h okay, minus 4, okay, but that's still one group right there, okay, because this one group is the next step of this particular group in the brackets. And then I'm going to subtract, and now I'm looking at, see, over here I have now 11 times 4 is a 44, okay, minus 4. So things now go completely numerical and all over h right there. I mean, I shouldn't say completely numerical, not quite completely numerical, but 44 minus 4 is a 40. 44 minus 4 is another 40 inside of that group. So in my next step, I'm looking at 40 plus 11h, okay, in parentheses for that group, and minus a 40, okay, coming out from this group, and then all over h. All right, so now I'm very close to the final answer. So now I'm going to step over to my other board and use the other space to continue my work here. So that space over there is not scratch work anymore. Okay, so now for my next step. All right, so now we're looking at removing or taking away the parentheses. So since there was positive sign in front of the groups, because there was positive sign in front of that group of parentheses, then when we take away parentheses, we don't have to worry about sign changes or anything like that. So in that way, now I am going to have just simply 40 plus 11h minus 40 over h. Okay, and now that is going to become simply just, now I recognize there are opposite terms here to be cancelled. So we're looking at 11h over h. Okay, and now just similar to how I did those problems where I was introducing the idea, and we have common factor of the h here. So every problem now at this point, once you've had your difference quotient set up successfully and your evaluation point is done correctly, then simplification step can take slightly different route here and there. It depends on how your function was at in the beginning. Your function f of x is depending on how it was given. Okay, so you gotta master your skills from your previous or your prerequisite course in terms of canceling out factors, canceling out opposite terms, and combining like terms, and all of those. Okay, and now canceling out the h here, I'm looking at 11. Okay, so this is my final simplified expression for the difference quotient. So this is called, that value right there, this is called, that's the simplified expression for what's so-called the difference quotient of f of x. Okay, this is f of x at x equals 4. That's how it's done. That's how it's done. All right, so now let's repeat to provide anyone another opportunity to see how it's done and to see how you can apply your understanding into setting up that difference quotient. So setting it up is the first thing you need to know once you learn about what that is called, and then we're going to evaluate it, and then we're going to simplify it. Okay, so now let me switch to a different function, and I call that part b of the example. All right, so let's now call that part b of the example. So the function given this time allow me to use a slightly or somehow a more complicated function, so that you just get comfortable. The idea now is just read that name and be able to set up based on whatever the function is given, whatever the function is given. Okay, so here minus 3x squared, okay, minus 11x minus 6. That's your function. Okay, and here we want to give at x equals, how about 5? At x equals 5. Okay, and so now from there, again, let's set up what we want. The goal of this problem, we want to set up the difference quotient of that function at this specific given value right here. So this is the part to be underlined. All right, and so now once again I need to remind anyone about what it means by anytime we're calling an expression the difference quotient. So upon having our function given right here, then the difference quotient is where we're doing the f of a plus h minus f of a over h, and a here is the previously given value right there, the value that's given in a problem that we're about to get it done right there. So in our case here, once we understand what the difference quotient is, let's go ahead and set it up. Let's set it up first. All right, so as far as the setting up, I'm starting out with f of, but now specifically a is 5. Okay, so I'm going to call that f of 5 plus h. Okay, minus f of, see, and so this is just for instructional purpose. You're not required to do this, but allow me to still writing this in red ink right here to catch your attention. F of 5 plus h. When you're actually doing this on your own, you don't need to write that in red ink. Okay, f of, and here it's 5 in red ink. And like I said again, that is just instructional purpose over h. That's what it is. That's the setup right there. So double check with that and compare with all of those problems we have done previously, so that you can really click and understand what it means or what it takes to set up a difference quotient on behalf of a given function at a specific value. I'm still working consistently with how I've been doing with those other problems earlier. Okay, and so now it's time to start evaluating, because here it's just the setting up, and now we're going to start evaluating it. Okay, so I see a fraction, so I'm going to draw a fraction bar right here. I'm going to draw that fraction bar. Tentatively, it's going to be long. And now I'm going to use some scratch work to work out, to show the evaluating step for this f of 5 plus h right there. Okay, so on my next board, on the space of my next board right there. All right, so f of 5 plus h. In this case, the ruler of our function says it's minus 3 times the square of every input, right? Minus 3 times the square of every input. I purposely leave that empty here just for you to understand whatever inputs, we're going to square the inputs and times minus 3. And then we're going to subtract 11 times the inputs, okay, and minus 6. And minus 6. That's the rule of the function. And the empty parentheses here is ready to fill in that expression, 5 plus h being the input, 5 plus h as the input. That's what it is. So this is now just that. It's good enough for evaluating the function f at this input being an expression 5 plus h, being that expression 5 plus h. Okay, and so now I'm going to copy and paste this. Yes, it's going to get lengthy at some point, but that's how we're doing math. Be patient. Okay, and so in my first board space right here, my formal work right here, I'm going to write minus 3 in parentheses 5 plus h all square minus 11, okay, times 5 plus h, okay, minus 6. Okay, so all that here is one group. Yes, my board is getting a little tight here. I understand. So all that group here in this pair of brackets is just a replacement as of the next step for what that is, for what that the f of 5 plus h is. But so we still going to need to subtract. Okay, we still going to need to subtract, and then here comes another group representing the evaluation of the function f at x equals 5 here. So here we're looking at minus 3 times 5 squared minus 11. Okay, I'm really out of space. Times 5, and then minus 6. Okay, so all that here is one more group right here, and we're going to divide all that. Okay, and that is a division. All right, and divide it now by h. All right, and so now this part right here will easily come out being a numerical value. Let's now spend some time foiling out that or expanding out that 5 plus h all squared right there, and together with all that minus 3. Okay, so now once again I'm going to need quite heavy scratch work right there. So on this board of mine, I'll think of this 5 plus h as a 5 plus h times 5 plus h. Okay, and then start foiling out. That's this, these two and those. And so now it's going to be a minus 3 times, so 5 plus 5 is a 25. 5 times 5 is a 25. 5 times h is a plus 5h. Okay, plus another, so h times 5 is another 5h here. And then h times h is an h squared, so now I can erase this because that's just some intermediate step right there. Plus h squared. Okay, but then there's still that minus 3 in front. Okay, and then minus, so the 11 times 5 is a minus 55 minus 11h, okay, and minus 6. And I'm working on this here completely on scratch work right now. And then the minus 3 comes in, so that makes it minus 75. And now I can also remove the parentheses here. That's the point, because we're now distributing that minus 3. Okay, and then minus 15. And here I can actually also combine the two like terms here. So that was a plus 10. These two combined together is a 10h. So together with that minus 3, so it's minus 30h. Minus 3h squared minus 55 minus 11h and minus 6. Okay, lots of like terms to combine and lots of like terms, the constant terms to combine as well. Okay, so minus 30h and minus 11h, okay, and minus 3h squared, and then minus 75 minus 55 and minus 6 right there. Okay, a lot of values here there to clean up right there. So how about minus 3h squared? That's the first term. These two together, the minus 30 and the minus 11, gives me minus 41h. Okay, and then those together with the minus 6, so minus 136 right there. Okay, all right, so now all of that here in terms of h, like that. Okay, minus 3h squared minus 41h minus 136. I'm going to bring this as a whole group into my actual setup right there, into my formal work. All right, so here I can write this as all that minus 3h squared minus 41h minus 136. Okay, that group right here represents the whole reduction work of this, okay, the whole simplification work of that, or foiling out and then distributive law and all that. And then I'm still going to need to subtract, and then all of that here comes in. Okay, so all of that here is going to be a minus 136 right here, all of this here together. Okay, minus 136. All right, so now, and over h. Okay, so now in my next step right here, then it's going to be a minus 3. Now we can just, now there was a negative sign here, but in front of the parentheses there was just a positive sign, so we can now just take away the parentheses without worrying about sign changes. So here it's going to become minus 3h squared minus 41h minus 136, okay, but then minus a negative sign here becomes a plus 136, okay, all over h. Okay, so the minus 136 plus 136, these two are opposite terms. We can cancel them away. Okay, and so in my next step now, so now we're so close to the final answer, I'm going to erase away this scratch work right here to write down the next step from my other board. All right, so as the next step, this is what I'm doing. We're looking at minus 3h squared minus 41h, okay, all over h. This is the next step right after canceling away the 136. All right, and so now I recognize, just like earlier problems, I recognize there's a common factor h in the numerator. I'm going to factor it out, okay, and now I'm looking at h times, in parentheses, minus 3h minus 41 divided by h. And now I can cancel the common factor h away. And so I'm left behind with a minus 3h minus 40 minus 41. But this is our final simplified expression of that difference quotient. So hey, what do we call it? This is the simplified expression of the difference quotient, of f of x, okay, at x equals 5. At x equals 5. So notice the point now is that once you know how to set it up, then this same problem, same function, I could have also written down with a different x equals a, like it could have been like x equals 1. Then you put a 1 here, okay, and then it's going to be very similar, but it's 1 here and 1 here, and then it's all the 1s here. And then, but your problem is going to work similar, but then it's not going to turn out into the exact same answer. Okay, all right, so that's example 1. And now after this, we're going to head out into example 2 right there for some different kind of problem with different intention like that. All right, but now, just right before we really getting into example 2, let me just simply write down 2 FYT problems so that anyone learning in this video lesson would have a chance to practice directly right here in this video lesson, so that you can strengthen your skill here about setting up and evaluate and simplifying a difference quotient. Okay, so now let me write down the 2 FYT problems. So there will be 2 FYT problems. All right, so the first FYT problem I want to introduce here. Okay, so how about that? So that exact same instruction, we want to evaluate. Basically we have to set it up first, right? And then evaluate and simplify the difference quotient. So now the function we have here is f of x being about f of x being given as 5x plus 7. And then this is at x equals minus 4. Okay, minus 4. All right, so this is an FYT problem, and so it's going to work just like how I was doing part A of the example 1 just now. So go ahead and spend your time on that. Feel free to pause the video, and then when you're done, I'm going to and resume the video. I am going to just tell you the simplified expression. All right, so at this point, your difference quotient should be after evaluate it, after set it up and then evaluate it. Now it should be simplified down to just simply 5, and that should be your final simplified expression for this particular one. Okay, and now let's look at another FYT problem right here. And so now how about your function here is being x squared minus 2x. Okay, and I want you to set up and evaluate and simplify that difference quotient at x equals about positive 4. Okay, and so again, this is another FYT problem. A little advice from me is that the way how this works is very similar to part B of this current example that we just finished. Okay, so now go ahead and take your time. Feel free to pause the video, and when you are ready and resume the video, I will just simply write down the final simplified setup of this difference quotient. All right, and so now at this point, that difference quotient here, we call it it's a difference quotient. We never had a formal symbol for a formal notation for a difference quotient, so just have to call that by name right here. But that final expression, simplified expression, should be just simply h plus 6. Okay, and that should be your final answer for that that difference quotient of this function at this designated value x equals 4. All right, and so now we really are ready for getting into example 2. All right, so in this example 2 right here, I am going to just stay with one function. How about we're going to let f of x, okay, be defined as x squared plus 3x plus 2. Okay, x squared plus 3x plus 2. And now, with that given function, part A of the example here. So I want to evaluate, let's evaluate, Okay, and if it's needed, if we need to set up, then go ahead and set up before the evaluation. And you kind of see where I'm going. So let's evaluate. And basically, yes, it means set up if needed. And then once evaluated, we're gonna simplify. Okay, so set up, evaluate, and simplify the difference quotient. And allow me to start using shorthand writing notation, the shorthand writing right here. So difference quotient. Okay, so that difference quotient of this function f of x. Okay, at how about specifically x equals 3. So now we have one designated problem. Okay, so now that's part A. And so let's go ahead and get it done. So hey, more practice opportunity for all of us viewing this video lesson right here. So there, that call has been made. We want to find the difference quotient. We want to evaluate the difference quotient, quotient and simplify. And so in that way, yes, set it up first is required, is needed here. And that's why I have that word set up in parentheses here. So that difference quotient, as the name is calling it, we need f of, okay, and then there's always that plus h thing, and then minus f of, okay, and then divided by h. This is the essential big part of a difference quotient right here. Okay, so it's a difference quotient in regard to your current function f of x right here. But now with this specific given point, okay, at x equals 3. So now we're looking at 3 plus h. Okay, see, so now f of 3 plus h minus f of 3. Okay, and then so that's the difference quotient as the setup point right here. So that reflects directly this definition that I'm still having on the board earlier. Okay, and so now from that setup right there, now we can go ahead and proceed into the evaluation work right there. So evaluating this function at 3 plus h is going to produce for me, and so we have done this often enough. So at this point, let me start skipping the scratch work part right there. So feel free to pause your own video, to pause this video at any point if you need to do your own scratch work. But assuming I'm already done with the scratch work, okay? And so the work here for that is going to be a 3 plus h, okay, all square plus, and then 3 times 3 plus h, okay, plus 2. So this group right here is f of 3 plus h. And now I'm going to subtract, okay, I am going to subtract, and now with this subtraction, I'm going to subtract the function at f at 3, f of 3. So now I'm looking at, so now 3 square plus 3 times 3, okay, and then again I'm running out of space here, so allow me to write this in a little bit narrower. How about let me really write it in smaller writing. Okay, so f of so that was 3 plus h, 3, and now we're looking at, so now skipping that scratch work step right there, we're looking at 3 plus h, all square plus 3 times 3 plus h, okay. So I wrote it down earlier, and I had short board space here, so I had to erase and rewrite the whole thing for here, plus 2, okay. And now with this one group here, now I'm going to subtract, and here we're looking at 3 square plus 3 times 3 plus 2. And now I'm making a lot better space this time, and divided by h. All right, so let's quickly explain my steps again. So just right here where this part where I group that in this pair of brackets right here, that just means whatever here is the end result by substituting in this expression 3 plus h into our current function, which is known as this rule: x squared every input square plus 3 times the inputs plus 2 for every input. Okay, and then we're going to subtract that same function here, but evaluate it at input 3. So again, that same rule for each input. We're going to square the inputs plus 3 times the input and plus 2. And that's how I set it up right there. And then again, more scratch work coming out for this. So allow me to work out on my next step without skipping the scratch work step right there. So I don't have to swing back and forth between the two boards right there. All right, so by working out on some scratch work right here, this square on this binomial will give me a 9 plus 6h, okay, plus h squared. And you have seen this multiple times, this similar problem multiple times, so you can always think of that as a product of two identical factor 3 plus h times 3 plus h. And this is what I get after foiling. Okay, and then I'm going to plus, and now this 3 is going to distribute for each term here, so that's making it 9 plus 3h, and then this is a plus 2, okay. All right, and so everything here is the end result of that FOIL version, okay, that FOIL version and distributed version of that. But it's still in the end, that's one group right here. And then I'm going to subtract, and then everything here we can now go ahead and proceed into the numerical calculation. And so that would be, so 3 squared is a 9, plus another 9, according to 3 times 3, plus a 2. So step by step, we're working things out, okay, and over h. All right, and so now at this point right here, we're going to have a lot of like terms and for combination, and then the opposite terms right there to cancel and all that. So I'm starting to run out of space right there, so I'm going to move over to the other board right there. So now on this board of mine right here, with the first term, and this part right here is supposedly the next step of that from that earlier step right there. So now I'm now going to take away the parentheses. So because in front of our parentheses here, there was just a positive sign, so we can just simply take away the parentheses without worrying about the sign change. But now here, when we take away the parentheses, then every term here must change sign, and you can also add all of these, sum up all of these terms together. And I don't want to do that instantly together with my steps here, so I'll just leave them there, but sooner or later we're going to combine them all together anyway. Okay, but I want to leave them there for some good reason. Okay, it saves me some calculation steps like that. All right, so now here's how, so after taking away the parentheses, and I have just now explained some sign changes. This sign will cause sign changes on these terms. So this is what it looks like on my other board as the next step right here. So 9 plus 6h plus h squared plus 9 plus 3h plus 2, okay? And then it is going to be minus 9 minus 9 minus 2 and over h. All right, and the reason I held on to the calculation for the numerical calculation, because we don't even have, I feel personally that it didn't even have to do that. Here's the reason. Now I have a whole bunch of cancellation. So why wasting so much of my effort, and then we're going to have to do a lot of recalculation here. So this 9 cancel with that 9. This 9 cancel with that 9 due to opposite terms. And this 2 right here cancel with that minus 2. And then this 6h will combine with the 3h here and giving me a 9h altogether. So in my next step, I even have enough space here remains for me to write my next step like that. Okay, so what I have left here is an h squared, all right, plus with the sum of these two terms. So now it's going to become plus 9h and then over h. And so now you have seen this action quite often prior to this point right here, but I have a common factor h. So now I'm going to factor out that common factor. So h multiplied with h plus 9, okay, over h. And now at this point, similar to earlier work, I can just cancel that h away, and my simplified final expression becomes h plus 9. So this is my simplified final expression that represents my initially the difference quotient of this function f of x. So h plus 9 that we saw on the other board was the difference quotient, the end result, the simplified final expression of this difference quotient. All right, so now we've had that. The next, and that's just, as I said, it's just, another practice opportunity for any one of us who follows along with this video lesson here. But let me now bring that into, and bring anyone into part B of the current example. So let's have a look at part B right here. So now I need to erase this. And part B for this example is supposedly very connected to the end result of part A that we have done previously. And so now allow me to write it down first. So I want to evaluate, okay, I just now notice right there. So I want to evaluate the difference quotient, okay, of f of x at x equals 3, okay, for, how about h equals 1. All right. So go ahead and spend some time writing down the instruction of the question in part B right here, if you have to. And this is for anyone who is learning along with this video lesson right there. Okay. And now after you have spent enough time writing down the problems, so here's the idea right here. You see I'm repeating that exact name right here. Evaluate the difference quotient, okay, of this same function at x equals 3. So everything remains exactly the same. And we want to evaluate that for h equals 1. And I did say it earlier that this problem in part B is supposedly very connected to the result we have had back in part A. So what exactly did I mean by that? This is what I mean right here. This difference quotient of f of x at x equals 3, we have already found it. We have set it up, evaluated it, and simplified it down to this point right here. So let me repeat that difference quotient for a little bit, or maybe the space at the other board is better in this case right here. All right, so now this is what we set it up. The difference quotient of the function f, okay, at x equals 3. Okay, so I wrote it all in black ink, but in the end, I still want to remind that this was that given value at x equals 3 right there. And this is, again, the name here is, it's this whole setup right here is called the difference quotient, okay, of the function f, or of the function f of x, right, at that given value x equals 3. And so we worked with we set it up, we evaluated that at these, and we simplified it down to, we spent a lot of work, and we came down to h plus 3. So this was the ending result for us at the end of part A that we already completed. Okay, and so now this is the intention for part B. Since we now know that at the end, the ending simplified final expression of this difference quotient, we ended up with an expression that's still dependent. I'm saying that word again. This expression is still dependent on the value of h. So in other words, h is still a remaining variable. Because now if we notice as part of the process, we introduced that external variable h right here. And then the work went on, and then in the end, some problem we came down to a final numerical answer, but most of the time, the problem came down with a remaining variable h right there, dependent on the variable h. And so the intention now is that for part B, the intention for part B is to take that h. So now when h is specifically assigned to be 1, then h plus 3, leading into the difference quotient that it's going to give us. So the difference quotient was already reduced down to h plus 3. But now that is going to be 1 plus 3. That's how simple that is. So just think about it. It's the next step after you have found that simplified difference quotient, but still dependent on h. And so now we're going to substitute this h for this 1 for h right here, and substitute that into our simplified expression. And so now I'm ending up with 4. All right, so that's one of it, which is easy. And so how about, since the work can start picking up pace here, how about h equals 0.1? Okay, so the same work here, but for h equals 0.1. So that means we're looking at 0.1, okay, plus 3. Plus 9. I apologize for that little error over here, but that was plus 9. That was plus 9 here. So this is 10, and this is a 9.1. Okay, and this part right here where I wrote it down, I also realized I just made that mistake right there. It needs to be plus 9. Okay, so now we can also try again. For h equals 0.01, then what can I say right here? Okay, that leads to 0.01 plus 9, and that leaves me 9.01, and this is our answer. Okay, this is our answer, and this is our answer for that. Okay, or a better way, even a better way of presenting our work. Okay, so really this is the end, but I would like to just shape up my way of presenting the work a little bit. So see, really in this problem B, it's 3 separate problems. So now we can sort of bullet the idea right here. So first bullet, for h equals 1, okay, then it's just 1 plus 9. The answer was 10. That's one of them. That's for that. Okay, and then we went on for h equals 0.1. Okay, then I can just say another bullet for h equals 0.1. Okay, then here's how we're doing it. 0.1 substituted for h, okay, plus 9, and we ended up with 9.1. All right, 9.1. And then for the next one right here. So now for h equals 0.01. Okay, and we're gonna have it's gonna be 0.01 substituted for h, and we're gonna add 9, and that gives me 9.01. All right. So this kind of problem, at this level that we're learning, I only want to introduce this kind of problem. My only intention for introducing this problem, just simply to get you equipped with that skill. Even the entire discussions about difference quotient, at this level, I'm still teaching anyone learning in this video lesson, as much details as I can, but I only intend to teach this as a skill that equipping you, as something that equips you with a certain good skill, so that this skills will become vital when you move on, when you arrive at your calculus course. So for now, keep this problem. Admittedly, I don't want to show too much applications of this because the real applications await at the calculus level course. So here I just want to put like a little stone in your foundation, so that as a skill that you are equipped with. Again, that's what I was saying earlier. I just want to bring up this problem and the whole idea about the difference quotient, even though I treat that formally as one lesson, but I want you to treat that as a skill that you are equipped with, so that when you arrive at your calculus course, this skill you will see the actual application of that. Okay, and this skill will become a vital skill. Okay, when you arrive at your calculus course. Okay, but for now, we just only take that as, for simplicity, it's just once, for this kind of problem, particularly once we have already set up the difference quotient successfully, right, from some previous work, and then we can go ahead and proceed. There were that kind of problem that we can go ahead and proceed into evaluating even further that difference quotient at various different h values. Okay, and then you can see I had an intention that I purposely put these values for h being smaller and smaller, and this is the kind of idea, that big idea where whenever you arrive at your calculus course right here, that idea will come out. Okay, that big idea will come out, and your professor there at calculus will explain what that is. Okay, what exactly this skill will bring for you. All right, so that is everything that we have about difference quotient.